Can the soaring promises of AI hype actually meet the physical reality of the universe? That's really the tension at the center of our discussion today. Because if you want advanced AI chips, the literal hardware that powers models like ChatGPT, the path runs through one machine, a single piece of equipment that costs $250 million.
It really is the ultimate physical constraint, isn't it? We're talking about extreme ultraviolet lithography or EUV. It's the very edge of what's possible in engineering, almost impossible to build. And without it, the dreams of Silicon Valley they can't happen. And what's fascinating is this brutal hardware race is happening just as Stanford experts are predicting a massive reality check for AI.
Welcome to the Deep Dive. You sent over a fascinating stack of sources this week, everything from top-secret Chinese prototypes being tested to the very skeptical view from Stanford's Institute for Human-Centered AI.
Right. Our mission is to take these two worlds, the cold, hard limits of manufacturing and the shifting expectations for AI, and connect them for you. So we've broken the dive into 3 areas. First, this pretty incredible breakthrough in high-stakes, super-secret chip manufacturing. Then we'll do a quick run-through of the ecosystem updates, app stores, new models, huge investments.
And finally, we'll spend some real time on why 2026 is shaping up to be the year AI has to stop demoing and start, proving it actually works.
Yeah.
And that's according to the very researchers who helped start this whole LLM boom.
Exactly. It's the journey from theory to accountability.
Okay, let's start with that foundational piece. EUV lithography, the $250 million machine. You said it's the bottleneck.
It is the single most critical choke point, to put it simply for everyone listening. Advanced chips, the kind you need for AI, are made by etching microscopic circuits onto silicon. EUV tech uses this incredibly precise high-energy light to print lines that are, they're measured in nanometers. And ASML, a company in the Netherlands, is the only place in the world that makes these machines.
The only one. That really says something about the complexity. But the huge news in your sources is that China has apparently built a prototype EUV machine.
That is the headline. Reuters is reporting it's now being tested in Shenzhen. Until now, this kind of manufacturing capability was just completely off limits to them because of geopolitical restrictions. So this prototype, it's a massive leap for their own tech independence.
Let's talk about the technical difficulty for a second, because it's not just another machine. What's the big achievement here? Your sources said the hardest part is just generating the EUV light.
Oh, absolutely. Think about what that means. To generate light waves short enough to etch at an atomic scale, they're taking molten tin, heating it to a plasma, then hitting it with specialized lasers to create the light, and then focusing it with mirrors that are almost impossibly sensitive. The fact that the prototype successfully generates the light, that's the huge win.
And what about reverse engineering? How much did that play into this?
It was crucial. The report suggests that former engineers from ASML were involved, helping to reverse engineer key parts and providing that deep institutional knowledge. It's a classic pattern, When a technology is heavily restricted, nations are just forced to pour everything into building it themselves.
So connecting this back to the bigger picture, the urgency was there because they couldn't just keep buying older equipment.
They couldn't. The license restrictions, mostly from the US and the Netherlands, got tighter and tighter. China was basically blocked from buying, fixing, or upgrading any of the top-tier ASML gear. Just maintaining their existing machines became a nightmare. It forced them to go all in on this. They had no other choice if they wanted to build their own next-gen AI models.
And the timeline. Even with a successful prototype, we're not talking about mass production tomorrow.
Not at all. The target for actual production is still 2028 to 2030. Building the prototype is just step 1 of a marathon. It buys the West time, but the fundamental problem, generating the light, seems to be solved.
I think that one anecdote you found really grounds how hard this is. The one about the Chinese engineers with the deep UV machine.
Oh, that story is perfect. So they tried to study one of ASML's slightly older machines, a DUV machine, by taking it completely apart. When they tried to reassemble it, they couldn't. The alignment was so critical, the tolerance is so fine, the machine just wouldn't work.
They couldn't get it back together.
Nope. They actually had to call ASML to fly in a team just to fix the misalignment they created.
That just highlights the astonishing precision needed. We're talking about a process where a single bump, a stray particle, or an atom-sized misalignment can kill a $250 million machine.
It's more like physics research than it is manufacturing.
Whoa.
Yeah.
Just imagine trying to scale that kind of precision, that complexity, to handle 1 billion user queries for an AI. That level of control over matter is it's almost unbelievable.
It really is. It defines the floor of global AI ambition.
So given this immense difficulty, How critical is success in this EUV breakthrough for China's long-term AI independence?
It determines whether they can truly build the chips needed for future advanced AI models.
Okay, that sets the hardware stage perfectly. Now let's pivot from the physical foundation to the digital superstructure, because things are moving incredibly fast at the application layer.
Right. This is where we see the development every day. The software ecosystem is basically trying to outrun the physical limits. Just look at the updates you found. On the learning side, Google's AI Agents course got 1.5 million learners in 5 days.
1.5 million in less than a week. That's a huge sign of global demand for this knowledge.
Yeah.
People want to be builders, not just users.
And now that course is completely free, which just accelerates things. Then on the deployment side, you have OpenAI launching the ChatGPT App Store.
That's a major move. It's not just a chatbot anymore. It's becoming an operating system.
Exactly. You can use apps like Apple Music, Photoshop, Spotify, inside ChatGPT. It's a platform. And here's the strategic part. They are already accepting app submissions for stuff that won't even roll out until 2026. They're locking developers into their ecosystem way, way in advance.
And on a lighter note, the model names are getting interesting. Meta is sticking with the fruit theme.
Yeah, after avocado for text, now they've got image and video models named Mango. It's a bit whimsical, but it shows they're diversifying fast, moving way beyond just text models into creative tools.
Meanwhile, competitors like Claude are stepping up their game.
Yep, Claude Code just dropped 4 big updates, including prompt suggestions and a plugin marketplace. They're focusing on the developer experience, trying to make it easier to build on their models to gain market share.
Okay, let's talk about the money. The investments keep circling back to that hardware problem we started with. Your source mentioned Amazon is in talks to invest $10 billion in OpenAI.
A textbook example of how this race is structured now. It's a circular deal. Amazon gives OpenAI capital, which they desperately need for training. In return, OpenAI agrees to use Amazon's custom AI chips. It guarantees Amazon a massive customer for their hardware.
And why is that circularity so important right now?
Because of the chip crunch, securing access to hardware is more valuable than just cash. This way, OpenAI gets the training capacity it needs and relies less on the traditional supply chains that are facing those EUV constraints. These deals are really strategic hardware partnerships.
And beyond the big players, there are some really interesting new tools popping up.
For sure. Look at Meta's SAM Audio. It can accurately separate any single sound like a voice or an instrument from a complex audio source.
Which is a huge deal for creators.
Absolutely. Then you have something like Bitrig, which can turn an idea into a real app on your phone, no coding needed. And then there's Cluely, which takes meeting notes and can give you real-time, undetectable answers during a meeting.
That one is fascinating and maybe a little unsettling.
It just speaks to how fast AI is integrating into our daily work.
So with these huge investments, like the Amazon deal, does this signal a slowdown or an acceleration in the AI race?
This shows major tech giants are doubling down on strategic, interlocked hardware partnerships.
Okay, we've covered the physical constraints and the rapid expansion of the application layer. Now for that reality check. Let's pivot to the shifting expectations for 2026.
Right, and this comes directly from the Stanford Institute for Human-Centered AI, or HAI. Their take is that 2025 has been the year of hype and demos, but 2026 is when AI has to prove it actually works.
And this critique carries so much weight coming from Stanford, doesn't it? I mean, this is one of the universities that fueled the early LLM research boom. Now they're questioning if all this investment, over $10 billion in 2025 alone, is smoke or fire.
That's the core of it. And 4 of their top researchers made some specific predictions. First one, no AGI. They think the industry will finally have to admit that there will be no AGI this year.
AGI being artificial general intelligence, that sci-fi AI that can do any intellectual task a human can.
Exactly. They expect companies to admit that AI hasn't really delivered big wins outside of very narrow areas, like code generation or call centers. The all-purpose AI is still a long way off.
And we're going to start measuring this stuff, not just talking about it.
Yes. They predict the rise of AI dashboards. Enterprises will start tracking AI's impact job changes, productivity shifts on a monthly basis. It'll be tracked like cash flow, like tracking steps on your watch.
They also pointed to one specific sector for a breakout moment.
A ChatGPT moment for healthcare, meaning we'll finally see breakout real-world deployments in clinical settings that get wide usage, and crucially, they'll have to prove they're safe and effective. That would be huge.
And for law, It seems like the novelty is wearing off.
Completely. The demo of an AI writing a simple contract is over. In 2026, law AI gets serious. The focus shifts from what it can do to what the liability is, how accurate is it, how risky is it legally safe to use this in court?
I still wrestle with prompt drift myself, just using these tools daily. Small changes in my input can give me these wildly different outputs. So I get why Stanford is pushing for verifiable, measurable outcomes instead of just flashy demos.
That's a really important point. It highlights the core problem: reliability. When you think about the billions invested, the scrutiny makes perfect sense. The industry has to mature from research project to reliable infrastructure.
So if general AI performance is slowing down, where does enterprise focus shift in 2026?
The focus will move toward measuring AI's impact on jobs and verifiable productivity gains.
So tying this all together, we started with the monumental engineering required for AI, that $250 million EUV machine.
And we end with this inevitable shift to scrutinizing AI's actual utility. Stanford's call for accountability. The main takeaway for you is that the future of AI isn't just about faster models. It's about solving nearly impossible engineering problems and delivering measurable, legally safe results.
That tension, the fight to build the physical foundation while the digital promises are being held to the fire, that defines this moment. And it brings us to a final thought from your source material. If the cost to make advanced chips starts with a $250 million machine, what happens to the accessibility of AI power globally?
It creates a tremendous divide.
Is only the wealthiest corner of the world allowed to participate in building the future of AI? That's a fundamental question of equity we need to keep exploring.
Thank you for sharing your sources and joining this deep dive with us today. It was a fascinating look at the limits of engineering and the limits of hype.
Keep learning, keep exploring, and we'll catch you on the next deep dive.